And so this, the rest of this section, so from this point on, the 4243 and the 11.1 stuff that we're going to go through is heavy use your TID9s. And so this is kind of a get to know how to use your TID9 section. All right, so let's talk about this problem. And because they tell you it's a linear growth, that means you're going to use a straight line, right, or linear function to model this information. And so what you can do is you can find how the pieces relate. So the date 2003 yields a population of 1722, and the date 2007 yields a population of 2874. So these have to be converted into ordered pair first. So if you write the corresponding ordered pair for those, okay, you can now answer your questions. And so if you want to make a prediction of what the population would be in 2009, the way that you would do that is you would take your calculators and you're going to find the equation of a line that passes through these 2 points. Now, conveniently, we created a function yesterday called 2 points. Okay, so what we can do is we can go into our var link, so second subtraction key, type the letter T, and then if you have to scroll down a little bit to get to the function that you called 2 points. You could also alpha lock your calculator and just spell the word 2 points. Okay. Now we enter our inputs in the way that we entered them or identified them when we created the function, which is we're just going to list our ordered pair. Again, no parentheses here, it's just a list. So it's 2003, followed by its y coordinate, 1722, followed by the next x coordinate, 2007, followed by the last output, the y value. And when we enter all 4 of those pieces of input, bless you, and then hit enter, we get our equation. So we see that the equation for this is 288x minus 575, 142. Now, it didn't ask us to write this equation, but there are possibilities or problems where it might ask you that. So if we were looking at the equation for this, we would get, oops, I'm going to use function notation here, but we would get that the population is a function of time. Right? And so I'm going to use here I had the 288x. Okay? I'm going to call it t here, but you can call it x. Okay? Plus, and my function was minus 575, 142. Okay? And so that was my function here. Okay? Now, in order for me to make the predictions from this problem here, if I want to predict what the population would be in 2009, I'm basically taking this function right here, and I'm plugging 2009 in for my t's. Okay? So I can do it a couple different ways. Right? I have my equation right here. One, I could copy this. So I'm going to hit diamond and then this up arrow. I'm going to copy that whole equation here, and I'm going to put it in my y editor. So when I get to my y editor, I can hit paste. So diamond escape. Now, the y editor already has the y equals, so I'm going to delete my y equals part from what I copied, and I'm putting my equation here. You could also just retype it there, right? Or you can just leave it in the home screen and not worry about putting it. Because I'm solving 2 problems with the same function, I'm going to go ahead and transfer it here to make it easier, but I'll show you how to do it both ways. Okay, so if you put your function into your y editor, what you can now do is you can simply call it y1 of 2009. Okay, and I can evaluate that. So my y1 function is this, and I want to evaluate it at 2009. And when I do, I get my answer of 3450. Oops. All right, so there's my population. Now, I had mentioned that you didn't have to put this into your y editor. What you could have done here instead, if you didn't do it this way, is you could have just highlighted your equation that you got after running the function 2 points. So you have your whole equation. I just brought it down. And you can use the with key, my vertical bar, and tell this x equals, and you're evaluating for 2009. So this allows us to do that evaluation, and I'm going to get the same number that I got from the function, okay, 3450. The second part of this equation asks in what year will the population reach a certain number. So if you're being asked to do that, what you have to do is set up a solve feature. Because what we're going to do is we're going to take this function right here and set this number now is the whole population, not just the t value, but the whole population. So you're going to say 5301 is equal to this whole thing. And we're going to solve for t the way I have it written here. And so this is one way that you can do this. Now, instead of having to write this all out, if you're going to solve it that way, you can go into your Algebra tab, select Solve, and here I'm going to type 5301, and then I'm going to just go up and I'm going to highlight my equation again. I don't have to retype everything, I'm just going to highlight it. Now, keep in mind here that my y equals, the y is being replaced by the actual number I'm testing, 5301. And so now I can go to the end of this. I want to solve this for x. And when I do, it's going to give me the year that this population would be reached. So I want it in decimal form. Okay, so I see that it's almost halfway through, right? 0.42, almost halfway through 2015. So my answer is 2015. Now, if I took the time to enter this into my function or into my y editor, I could also have done this using function notation by using the solve feature. 5301 is equal to, and I would type in just my entire y1 of x, my basic form. This calls up the function that's stored in the y1 of the y editor, and I want to solve for x. And so that's what I could type in as well. So if I hit Algebra, the Algebra tab, F2, choose Solve, and then access my y1 of x, set that equal to the value I'm testing for, solving for x, and it will give me the same number, in decimal form here, the 2015.